Hello, welcome back to the Manufacturing Connector Essentials Series. I'm at the Siemens booth in the East Hall of IMTS with John Regulski. Did I say that correctly?
Yeah, that's great.
I'm like Ron Burgundy from Anchorman. I just read it phonetically, right? So, John, tell us a little bit about yourself, how you got into this role today.
Okay, well, I started out about in 2005, worked at GM for a while, and then came in and worked on the hardware side of the business, selling tool presenters for various companies out there.
No kidding.
And yeah, in 2021, I worked with a gentleman from TDM that moved over to Siemens, and he brought me in to sell some of the software side of the business.
Awesome.
So yeah, so I've been here about 3.5 years now, working with our Machinum portfolio.
Awesome.
Which is software from the CAM side of the business out to the shop floor to make machines more profitable, keep them fit, and see if we can last them for a long time.
I love that. Fantastic. So you've got a couple of different stations you're going to walk me through today. Is that correct?
That is correct.
Awesome. Let's come next to me here and let's talk about what you got.
Okay, what we did here for our concept is, again, Machinum is our theme is a gym workout. So we want to make the customer's machine last longer. We want them to be fitter, and we also want to help them reduce some cost in the making of any parts that they do.
Yeah.
So what we did here was we had the theme of a golf putter. So what we did was we used we conceptualized the part as we started out from scale to low volume production. Then what we did, we put it in the Siemens ecosystem. So we started out in NX CAD, and we had that theory going with the putter design. What we did was for that the first iteration was a 5-axis putter. We took a full billet and we ran it through the process. So we looked at our cycle time as 2 hours and 15 minutes with a material cost of $75.
Oh.
Well, we had a machine tool dealer here that copied our part a little bit.
Okay.
So we said, let's one up them because they're using 5-axis machines. We're going to see if we can reduce our cycle time and our part costs. So what we did was we then took the putter and we said, what if we break this section down and we break this section down and have two parts, machine two parts, put it on a fixture. And that's what we did. So as you can see here, we reduced our cycle time 30 minutes and also reduced the material cost $30.
And that's per part.
That's per part.
So you're making 3,000 of those, 30,000 of those, 300,000 of those. That's just exponentially saving people money.
Exactly.
Awesome.
So then here's how we set up the fixture. So we've got our plumber shaft. I learned that this week from a Titleist group. So that's called the plumber shaft. And then the head of the putter here, and we put them in a fixture, set it up. Then what we did was we put it in our application called Run My Virtual Machine. Run My Virtual Machine is the digital twin of the Siemens 840 or Cinemeric 1 control.
Okay.
Brought it in here, and we looked to see how we can machine this operation without going out and using the shop floor and wasting their time. We brought in our adapter and our tooling, brought in our fixturing, and now what we're doing is we're just seeing how that part is going to run and if we need to make any corrections.
Wow.
We can visually look at inside the machine and visually look at the tool removing the material. And what's unique or nice about this is we can even change the tool color so we can actually see that material being removed. A lot of times CAM operators will move that around and they can't see the material being moved until they get out to the shop floor.
Absolutely. So this will drastically reduce that opportunity for scrap because they have that color change and they're able to see that material being removed.
And we even haven't got out to the shop floor yet. This is right at the desk.
That's amazing.
Yeah. We can also, once on other applications, we can take the archive from the Run My Virtual Machine and we can put it in an application called Analyze My Workpiece Toolpath. So we can actually see the tool path of the machine and also maybe adjust any surface finish anomalies that we need to do. So we can do a lot more before we even get it into the shop.
That's awesome. Yep. Wow.
This will show you any crashes or, like I said, any characteristics that could stop the machine or have issues, spindle issues. So
So did you learn a lot about putters through this project?
I didn't make any of the stuff, so yeah, but I'm learning as I go on. So once we get done with the program here, we walk over to the actual machine and we bring the program in to the machine. How can we optimize this even more? Well, what you see on the left-hand side here is the program being run in a training mode. So what this is doing, it's looking at the program itself, looking at the in and out of the cut, and based on spindle load, we're going to dynamically change how that program is going to be run into the machine. Once it learns the program, creates a tool profile, creates the information in the background of the tool, we can then switch it into operating mode. And as you can see, we've got our feed rate set at 100%, and dynamically it's changing that feed rate as it goes in and out of cut. Adaptive control is a great application. The best ROI out of the box, we see between 5 and 18% cycle time reduction.
Wow.
And that's all based on spindle load. So as we move into the cut, we'll reduce our feed rate, so we're protecting the tool. We see a lot of chips and broken tools as we move right into the material. As we gradually get into that, we increase our feed rate, and we're protecting the spindle and the tool, getting more tool life. And as you can see, we've saved 17% on this putter.
Look at that. Wow, that's great.
So some of the other applications we have in our Machinum portfolio, and you can see we've got a lot of applications that aren't a part of Machinum, but you can see the hand there with the leaves. That's our sustainability. So a lot of our applications have that sustainability in mind for companies to, again, reduce their energy costs too. Some of this is going to help them do that. Protect My Machine 3D Twin is an application where we can look into the future. So we'll have a tool that is set up virtually versus where the tool is in the spindle. So we can actually, the tool can actually, the program will actually take a look at that tool before it hits the workpiece to protect the machine, see if there's any crashes before that happens. So we can look into the future and hopefully protect our machine on that.
I love it.
Manage My Machines Remote is a good application for OEMs and for customers, as well as if there are any issues with the machine's program changes that need to be made, a OEM can call into the machine and help that customer adjust the program or fix that machine.
That's amazing.
Remotely. Manage My Resources Tools is a tool management program, part of our M Center platform. And what that is a centralized database for our tools, programs, and our performance. So we can basically see where the tools are at in the area, in the shop floor. That way we don't have to either, break them down or reuse them. We can actually go get that tool and put them in another machine if it's needed.
Sure.
Automate My Visual Inspection is a application where we will put a camera in the machine and it'll snap so many pictures on a setup of a machine. So if we see a screwdriver, if somebody leaves something in there, it won't allow the machine to start until that screwdriver or screw is removed from that application. We went through adaptive control.
Yep.
Analyze My Performance is a great application for monitoring your machines in the shop, allowing you to see your actual plan versus your work plan that you came out with. So why is my machine only running 4 hours when our actual plan was 8 hours? So it allows you to performance. Create and run my virtual machine we saw over there. And Analyze My Workpiece Monitor is an in-process quality check. So we can put an edge device in there and it can capture high frequency data, create data models so that anything below or above upper and lower tolerances, we can stop the machine and continue on. So we don't have to do as much offline in-process checks.
That's awesome. Fantastic. All right.
That's part of our machine portfolio.
John, appreciate it.
Appreciate it. Thank you.